Welcome, Wildcats. Today we are going to be starting our next section, which is the beginning of our next unit. In this case, Unit 4. And Unit 4 is everything to do with polynomials. We're going to be talking about addition, subtraction, multiplication, division, factoring, basically everything you can do with a polynomial that it helps you in real-world situations. However, today we're going to start very simply, and we're going to start with adding polynomials. There are, of course, since we're starting a brand new unit, a couple of things that we need to keep in mind from a vocabulary point of view. So let's take a look at the important vocab words for Unit 4, Section 1. First of all, a monomial, or a monomial, is a number or a product of numbers and variable with whole number exponents. That's the textbook definition. Basically, a monomial is simply a number, a variable, and an exponent. That's really all it is, all multiplied together. A polynomial, on the other hand, is a sum or difference of monomials. Give you an example. 2x squared is a monomial, but 2x plus 3x squared minus 2 is a polynomial because you have 2x, 3x squared, and negative 2 are all monomials, and we're adding or subtracting them together. That makes it a polynomial. A polynomial in standard form, what I have on the screen right now, this px equals a sub n to the x, that is a mathematician's terminology for what a polynomial in standard form is. Here's what you need to know, though. Take whatever polynomial you're talking about and order the monomials from largest to smallest. So if you have 5x to the third minus x squared plus 7x minus 3, our exponents go 3, 2, 1, 0. And that gives us standard form for that monomial. A lot of times you're going to be asked what the degree of a polynomial is. Luckily, it's incredibly easy to get. All you have to do is take a look at the largest exponent that you see for a monomial, and that is your exponent. So in the previous example that we had, what was its degree? Yeah, we had x to the third power was our largest exponent, so 3 is our degree. The last terminology that we need is leading coefficient. Luckily, it's just the number out front. It's the coefficient of the term with the highest degree. So if you write everything in standard form from left to right, then the leftmost number is your leading coefficient. Again, in the case of the previous example, that would be the 5 that's being multiplied by the x cubed. So 5 is our leading coefficient in that example. Here's how we're actually going to go through the process of adding these. There are multiple ways, but I am only going to show one of them, the one that I personally feel to be the most straightforward and simple. First, you need to write all of your polynomials in standard form. If they're already in standard form, great. But if they're not, we need to rewrite them. Second, we're going to stack our polynomials up one over the other. Finally, add each of the individual terms together. So, here's an example. Taking a look at the polynomial on the left, what is the largest degree that you see? Yeah, you have that x to the 7th power there. And the monomial that goes with is negative 7x to the 7th power. So that needs to move all the way over to the left and be the first thing that we see. That's the first step to getting the polynomials written in standard form. So when I look at this, I see that I have an x to the 7th, then x to the 4th, x to the 3rd, x squared, and then a constant. And that's the order that I need to rewrite them in. X to the 7th, x to the 4th, x to the 3rd, x squared, constant. And do make sure that all the signs go with them. So the 7x to the 7th was negative. The x to the 4th had a 12 next to it, so it becomes positive 12x to the 4th. And once we've got all of those, we look at the second polynomial, and we see that 14x cubed minus 9x squared plus 14 is already in standard form. It goes from largest to smallest. When I say stack them on top of each other, here's what I mean. Take whichever one of the two happens to be the longest and just write it in standard form. Take the other one and write it under it, making sure to line up equal terms. So you'll notice I had an x cubed term in both and an x squared term in both, and I went ahead and I stacked those on top of each other. I also had a constant term in both polynomials, so I put those on top of each other as well. Now when I add, all I have to do is add straight down. So negative 7x to the 7th doesn't have anything to partner with. Neither does my x to the 4th. Those just go straight down. 14x cubed and negative 6x cubed. When I add those together, I have a negative plus a positive. So I'm going to actually subtract them. 14 minus 6 is 8. So I have 8x cubed, and then I have a positive 9x squared and a negative 9x squared. Those cancel out to 0x squared. And then I have the 5 plus my 14, which is just 19. Now I have boxed this as our final answer, but do keep in mind that technically if we're going to write this in standard form, we actually need to get rid of the 0x squared. Because now that it has 0 as its coefficient, 0 times anything is simply 0, so it goes away. And our final answer that we would actually put into HRW would be negative 7x to the 7th plus 12x to the 4th plus 8x cubed plus 19. As you can see, we really haven't done anything other than rearranging and then adding and subtracting different numbers together. Both of which are things that you guys have been doing for so many years that it's not even funny at this point. For example 2, once again, we're still going to write all the polynomials in standard form. We're going to stack them on top of each other in standard form, and we're going to add all the terms together. So, here is our two equations. Once again, I have a 7, 4, 3, 2, 0 on the left, so that's x to the 7th, x to the 4th, x to the 3rd, x squared, and a constant. And if I rearrange those in the correct order, I get 7, 4, 3, 2, 0. 7, 4, 3, 2, 0. However, this time on the right, I also needed to change my order over there. I had x cubed, x to the 4th, and then just x. So now I have 4, 3, 1 as my exponents, making sure that all of the coefficients and all of the signs stay with the original number. Now when I stack these on top of each other, you're going to see something very important. Notice I left a space here in the top one. I put my negative 3x to the 7th plus 5x to the 4th minus 2x cubed plus 6x squared, but then I left a blank space. And that's because when I looked at my second one, my second polynomial, I saw that it had an x term. But my first polynomial didn't have that. So when I go to stack the second one underneath, I need to make sure I have some place to put that. Once again, we're just going to add all of these numbers up. So I have negative 3x to the 7th. And then when I add 5 and negative 9, I get negative 4. When I add negative 2 and negative 2, I get negative 4. 6x squared is by itself. 14x is by itself. 9 is by itself. So most things just come straight down, but I do need to make sure I combine like terms on the other two. Now I look to see if there's anything I need to eliminate. In this case, I don't see any zeros, so I can just box this as my final answer. Do notice that I don't have an x to the 6th or an x to the 5th, but I don't leave space for those and I don't put a 0x because they don't exist. With that, guys, that's really all there is to adding polynomials together. All you have to be able to do is combine all of the like terms after putting them in order, stacking them on top of each other, and you should be good to go. As always, if you have any questions, you know you can find me through email, or if it's an HRW problem that you want help with, if you choose, you can always take a look at the HRW tutorial video that I put together there. Good luck, Wildcats.